Here we're asked to use the graph to determine the average rate of change of the function from x equals 0 to x equals 1 and from x equals 2 to x equals 5. To find the average rate of change of a function, we need to find the change in the output and divide by the change in the input, where the change in the output would be the change in the function values or y values, and the change in the input would be the change in the x values. So the first step is to find the coordinates of the points at x equals 0, 1, 2, and 5. When x equals 0, we're on the y-axis, right here, where the coordinates would be 0, 6. When x equals 1, we'd be here. The coordinates are 1, 9. When x equals 2, we're here. The coordinates are 2, 6. And then finally, when x equals 5, we'd be here, where the coordinates are 5, 21. Now that we have the coordinates, we have our inputs and outputs. The inputs are the x coordinates, and the outputs or function values are the y coordinates. Determining the average rate of change is actually the same as determining the slope between 2 points. So to find the average rate of change from x equals 0 to x equals 1, we'll use this point and this point. And referencing our formula, we'll call this x sub 1, y sub 1, x sub 2, and y sub 2. So to find the change in the function values or y values, we'd have 9 minus 6 divided by 1 minus 0. So we'd have 3 over 1, which simplifies to 3. So the average rate of change is equal to 3. But to interpret this, it's often helpful to leave it in fraction form. If the average rate of change is 3 over 1, that means on this interval, on average, the function value or y value will increase 3 units for every 1 increase in the input or x value. To find the average rate of change from x equals 2 to x equals 5, we'll use the coordinates of this point and this point. We'll first find the change in the outputs, or the change in the function values, which would be 21 minus 6. Divide by the change in the inputs, or x coordinates, 5 minus 2. So we have 15 divided by 3, which is equal to 5 over 1, or just 5. So what this is telling us, on the interval from 2 to 5, on average, the function value will increase 5 units for every 1 increase in the input, or x value. Let's also interpret the average rate of change graphically. The average rate of change from x equals 0 to 1 was equal to 3, which is the same as the slope of this red segment here between the 2 points. And the average rate of change from x equals 2 to x equals 5 was equal to 5, which is also the slope of this green segment. Okay, that's going to do it for this example. I hope you found this helpful.